In section 3 here, we're going to look at the production and consumption of oil. We're going to begin by focusing on OPEC, the Organization of the Petroleum Exporting Countries. Most of these are in the Middle East: Qatar, Saudi Arabia, Iran, Iraq, Kuwait. Some of them are quite surprising. Venezuela is a member of OPEC. It's actually one of the top producers. If you look, Saudi Arabia produces 32%. There's Iran over here at 12%, and Qatar, oh, that's Qatar, sorry, Nigeria at 10%, and then you have United Arab Emirates and Venezuela at 9%. So it's in the top 5. Do I count that right? 1, 2, 3, yeah, top 5, top 4, top 5, however you want to think about it. Here is a graph of oil production versus consumption. On the right-hand vertical, we have crude oil in millions of barrels per day, and on the, oh, that was the left hand. On the right hand, it's in billions of barrels per year. The bottom axis is time. Production is this line down here, and then it turns blue and follows over here. And consumption is this line. If you look at it, when reserves are found, production equals consumption. Not a surprise. Right? Absent new discoveries, production goes down. So that is this dip here. Production went down in the lower 48. Right? OPEC hiked prices. Consumption decreased, which is here, which inspired us to go look for a different source. So we started looking at Alaska. When we were able to produce in Alaska, that gave us a peak in consumption because prices went down again. Our consumption is directly related to price. So what are we doing today to deal with gas prices? What are we doing? Here is a table of the CO2 emissions per unit energy for fossil fuels. Natural gas 5 has been set to 100% and everything else based off of that. Everything else produces more. Gasoline, crude oil, and then coal at 178%, almost double. This is a graph of the CO2 emissions per capita as of 2013. The U.S. was at 19.9 in 2013. This changes. It's not fixed. So if you click on the World Bank link, which remember you can access the PowerPoint in the resources folder and go play with these all you like, we can see that in 2010 and 2011, the United States was 17.5 and 17 per capita. And we're not the biggest emitter. Qatar is. If you look at the other link here, Gapminder, it allows you to graph usage as a function of time. So again, if we scroll down and choose the United States, and then move it forward in time, we can see that our CO2 emissions have steadily been increasing, though it looks like maybe they're down a little bit here at the end. Okay. If we look at Qatar, which was the top user from the other slide, what is it doing? Qatar, let's get is as a function of time as well, just scroll back and forth, doesn't have as much data, but you can see all of a sudden it spiked and then has been erratic ever since. I encourage you to explore this site as well on your own. So what are our options for the future? We can exploit more reserves, like drilling in the Arctic National Wildlife Refuge, ANWR, or drilling offshore, but we've already shown that drilling offshore causes potential problems. We can increase conservation, use less fuel. We can improve efficiency. Are there other options, other possible futures? Here is a picture of the Arctic National Wildlife Refuge. Here is an explanation of the refuge. It is the largest refuge in the United States, and the proposed area for drilling are the most sensitive areas in the entire refuge. Here is a picture of drilling on the North Slope, also up in Alaska. Here's something a little closer to home, the Marcellus Needmore Shale. It's a source of natural gas. It's caused an increase in the value of drilling rights in the area which it encompasses. Most of Pennsylvania, most of West Virginia, a little bit of Ohio, a little bit of New York. Right. To access this source, put in a well, drill down to the shale, and then turn horizontally. In order to access the natural gas within the shale, it requires fracking, which has another whole host of environmental impacts. Here is a picture of a sample of the shale. This is a plant spore with some pyrite grains in it. The rest is just rock and a clay matrix with an organic stain. So as with coal, if we're going to rely on oil, we need to look at the footprint. Not only how big is the well, how big is the well, but what do we have to do to get the oil from the well to where it is needed, to refine it, to get it ready for use. Think about pipelines. Think about transportation. What are the implications of all of that system for soil, air, water, biota? What is the efficiency? How can we improve it?